Hello, welcome to Advanced Composites. Today is the last day of this week, which is the 6th week of this course, and what we have discussed throughout this week is solutions for semi-infinite plates. In two cases we have solved the situation when the plate is symmetric, and now we are working on plates which are having unsymmetric lamination sequences. And for cases C and D, we have developed the solutions for U, V and W as well as for Mx, My and Mxy and B12, and we have found that instead of just a simple D11 we get a reduced bending stiffness term which is script D11. Similarly, in the denominator in the expression for Ux we have a script A11, and in both these cases what we see is that the presence of bending coupling matrix, coupling stiffness matrix, it tends to reduce the bending stiffness as well as the in plane stiffness of the plate. So, that is one thing. The other thing is that we have till so far not calculated the integration constants C1 through C8, and the value of these constants will be determined by implementing the boundary conditions. So, that is what we plan to do now. So, we have all these solutions for U, V, W, also for Mx, My and Mxy, and the next thing we are going to do is we are going to implement the solutions for these integration constants. We are going to calculate these integration constants. One thing I omitted writing in terms of the solution in the last class was that I did not explicitly write down the values of n's. So, Nx is equal to C1 and Xy is equal to C2. Okay. So, that is still there. So, now we apply the boundary conditions. And the first will be for case C, and in case C the BCs are U equals V equals W equals Mx equals 0 at x is equal to minus a over 2, and here it is Nx is equal to Nxy is equal to W is equal to Mx is equal to 0 at x is equal to plus a over 2. So, Nx is equal to C1, but at x is equal to a over 2, Nx plus is equal to 0. So, therefore, C1 equals 0. So, we have implemented the first boundary condition, which is this one. Okay. Next, we apply the second boundary condition, which is on Nxy. So, we know that Nxy is equal to C2, but at x is equal to a over 2, Nxy plus is equal to 0, therefore, C2 equals 0. So, now we have implemented two boundary conditions. The third is we will see what is V. So, Vx is equal to C6 plus C2x times 1 over A66. Okay. But we know that V naught is equal to 0 at x is equal to plus minus a over 2. So, if that is the case, so therefore, C2 is equal to C6 is equal to 0. So, V naught x is 0. oh I am sorry, V naught is 0, not at x is equal to plus minus a over 2, it is just at V naught is 0 at x is equal to minus a over 2, and C2 is already 0, we have calculated it. So, C6 also comes out to be 0. Okay. So, we have implemented now 3 boundary conditions out of 8. Okay. The next boundary condition we will apply will be on M. So, we know that Mx is equal to minus Qx square over 2 plus C3x plus C4. Okay. But we know that Mx is equal to 0 at x is equal to plus minus a over 2. So, we do all these, we apply both these boundary conditions and we find that therefore, C3 is equal to 0 and C4 is equal to Qa square over 8. So, because of that Mx is equal to Qa square over 8 minus Qx square over 2, same relation, or I can have the same expression which is this Mx is equal to k square over 2 times 1 by 4 minus x by a whole square. So, this is my relation for Mx. So, now we have applied 6 boundary conditions. Okay. So, we have calculated the value of C1, C2, C6, C3, C4. Okay. And what we have not yet implemented are conditions on U and W. So, those are the conditions which have not yet been implemented. So, the expression for W is this long thing, okay, and let us implement the. So, we know that W is equal to 0 at x is equal to plus minus a by 2. So, if we implement this condition, implement it in equation for W naught x, what do we get? We get 2 conditions. C7 is equal to C5 times B11 by A11. This is one condition we get, because when we implement this condition in this equation for W, this term has to be 0. Okay, this term has to be 0. So, when we do that, we get this relation, and we also get the other thing, and C3 is already 0. So, that term also goes away. So, so the other condition we get is C8 is equal to 5 Qa4 divided by 384. So, if we put all these things together, what we get is W naught x equals a to the power of 4 times of course q divided by 384 subscript d11 into 16 x by a 4 minus 24 x by a square plus 5. So, we have now applied 7 boundary conditions. So, the only boundary condition which is left is now on u. Okay. So, now we apply the 8th boundary condition which is on u, and we apply on the equation for u naught. Okay. So, applying the BC on u naught, x is equal to 0 at x is equal to minus a over 2. what do we get? We get ultimately, this is the equation we get if we do the math carefully. So, this is equal to B11 Q A cube divided by 24 subscript A11 times D11 into 4 x by A cube minus 3 x by A plus 1. Okay. So, we will compile the results. So, u naught x, so these are the results for case C. So, what are the equations? The equations are u naught x is equal to B11 Q A cube divided by 24 subscript A11 times D11 4 x over A cube minus 3 x over A plus 1, and V naught is equal to 0 and W naught is equal to QA4 divided by 384 D11 16 x over A minus 24 x over A plus 5. Oh, this is to the power of 4 and this is to the power of 2. Okay. So, these are the relations we get for W and for U and V, and what we will do is we will continue this discussion next week also, because this is what we have solved for case C. Similarly, what we will also do is we will solve for case D and see whether these solutions are same or different. So, that concludes our discussion for today, and I look forward to seeing you next week at the same time, that is on Monday. Thank you very much. Have a great weekend. Bye.